Greetings, everyone. My name is John Gabriel, and this is the New Calculus channel. So today, I'll be talking about a very important topic, that of real numbers. So let's begin. Now, in previous videos, I discussed quite a lot about number theory, and the purpose of this video is to explain to you that natural numbers come from rational numbers. They're actually a special type of rational number. And that unless a number is a fraction, it's not really a number. It's not actually a number because the only numbers are rational numbers. There is no such thing as an irrational number. So, modern Greek academics call rational numbers using the expression riti arithmi, where riti means explicit or callable or mentionable or recitable, as in poetry. Unfortunately, most of them have never understood the elements of Euclid, and I only know of one Greek PhD who agrees with my views and shares the same sentiments and opinions as I do. It's a shame because modern Greeks are not even a shadow of their ancestors. So in Book 7 and Definition 1, we see Euclid attempt to define the abstract unit. He didn't do a very good job of it because it's not a very good definition. So Greeks today will call incommensurable magnitudes by the name arithmi. And arithmi means irrational, whereas riti means rational. So I was the only human after Euclid in these last 2,500 years to understand these things. Even Sir Thomas Heath, who translated the elements, and he did a pretty good job out of it, didn't really understand what Euclid was attempting to do. So the definition in Book 7 says, monas estin kath in ekaston ton ondon and leite. So the literal translation is this, which doesn't make much sense to anyone. Single is for each of the beings called, okay? So each single object is called a unit. Now, the idea of unit is derived directly after a ratio of magnitudes is established. And if you click on this link, you'll understand that. And of course, this video explains more. So in Book 5 and Definition 3, we see the definition of a ratio. Logos esti dio megathon homogenon I kata pilikotita pia siesis. And that literally says ratio is two magnitudes homogeneous or toward quotient what relationship. A more meaningful definition is a ratio is the comparison of two magnitudes with or without a particular relationship. Now, the word pilikot today means quotient, but any astute scholar will see that this is not meant in the same sense as it was interpreted back in classical Greece, because the idea of quotient comes after ratio is established. So, for example, the ratio circle circumference to diameter, which is the symptom of pi, it's not pi because to be pi, it has to go from ratio to a number. And normally when it goes to a number, we use the vinculum or the slash. And we can only do that if both these aliquot parts, circumference and diameter, have a common measure. They do not, okay? So piliko refers to a possible proportion, but not necessarily one that is known. So we can see that all the arithmetic operations in this link were established geometrically long before Book 7. And of course, Euclid, sticking to chronological order, would introduce the abstraction of measure from geometry to algebra in Definition 1 of Book 7. And we see fraction being defined in Definition 3 of Book 7. It says, a number is a part of another number, the lesser of the greater, when it measures a greater. And of course, in the Greek, it says, meros estin arithmos, arithmu o elason, tu mizon nos, otan katametri ton mizona. So that's basically what it means. The above is the definition of a fraction. By the way, people, to all those who deny that the Greeks knew about fractions, meros means part, okay? meros estin arithmos, part of a number. And I'll give you an example here using this very same definition of Heath. A number 4, it's actually 4 over 1 because 4 is also a fraction, is part of another number, 12 over 1, the lesser of the greater when it measures the greater. Okay, so 4 measures 12. Can you guess the fraction in this example I gave you? If you guessed 1/3, bravo, you did very good. Now, Thomas Heath was mistaken because in one of his footnotes he says, in other words, a number p is part of another number q if there exists some number n such that n times p equals q. But that is obviously nonsense because the general definition of magnitude is given in Book 5 in a very similar text, okay? And this is what it says. A magnitude is part of another magnitude, the lesser when it measures the greater. So to become a number, you start off with a ratio of magnitudes, and if the lesser measures the greater, it means that both the aliquot parts have a common divisor, okay? And so Heath's definition is laughable because multiplication is derived after the quotient, piliko, and not division, diaresi, which is thought to be synonymous, okay? The word for division in Greek is diaresi. So division is established after the quotient, and then comes multiplication. So Heath's division would also be circular because n is equal to p over q implies that the rational numbers have already been established. How could n be a number if numerator over denominator had not been defined? It's preposterous, isn't it? So in definition 2, we can say in the greater is a multiple of the lesser when it is measured by the lesser. So this word poloplasion that you see here, poloplasion, came long before the word multiplication, okay? And the above definition uses a word which originally meant more than one of the same kind. It did not mean anything to do with factors yet because numbers had not been established. So the word multiple has its origins in poloplasion and today is only considered in the sense of a special category of rational numbers called natural numbers or integers. However, it can apply to a magnitude as well. Yes, any magnitude can be a factor, okay? So, I mean, if you have a distance of 2 pi as a magnitude, it has a factor of pi, and that's not a number, okay? So, we could write Book 7 and definition 3 also in the reverse sense. Number 12 is greater than number 4 when equal parts of the greater measures are smaller. And that number, by the way, is obviously 3 over 1, okay? So if you guessed that, well done. However, by definition, both 4 and 12 are fractions, okay? 4 is 4 over 1 and 12 is 12 over 1. And 3 over 1 is also a special rational number that is called a natural number. So apparently Euclid didn't bother either in Book 5, where he was working with magnitudes, or Book 7 to state the converse because it was pretty obvious to the ancient Greeks. There was no need to do it. Anyone who denies this is true is a fool. I mean, please, do you think they were that stupid that they wouldn't see the converse of it? So with this, I think we can finally put to rest any idiotic notions that natural numbers came before rational numbers, which are the only well-formed numbers. Okay, there is no such thing as any rational number. There is no valid construction of real number. Not Dedekind cuts, not classes of equivalent Cauchy sequences, or however you want to word it. All that is absolute rot. And of course, imaginary numbers like complex numbers are not numbers. They're just very different mathematical objects. Okay, and they shouldn't be called numbers. So I wanted to leave you with this information, telling you that my articles, my website, and YouTube channel are a labor of love, okay? They're truly a labor of love. And what makes this even more remarkable is that my good deeds have not gone unpunished by my innumerable enemies in the mainstream. They hate me, they're jealous, they libel, denigrate, deceive, and their actions have all but destroyed my life. Now, I consider it a good sacrifice for the future of young, aspiring mathematicians, and I hope you will remember that it was I who coined the phrase, The objects that arise from concepts in a mathematician's mind are only as appealing as they are well defined. Okay, so if being called a crank means that I reject many mainstream views, then I wear that label proudly. On the other hand, a crank is one who cannot be convinced with reason or by any other means. In other words, most mainstream academics are cranks who cannot, and more importantly, will not be turned from their false beliefs. I'm the great John Gabriel, and I say great because I truly solved the tangent line problem, not Newton or Leibniz. They messed up really bad. I mean, Newton and Leibniz were just experimenting, and they were in the dark about many things. And of course, the fools who came over after them with their epsilon, delta arguments, and that ubiquitous definition of derivative and integral, they were all wrong. And in my new calculus, there are no ill-formed concepts such as infinity, limits, and all that other nonsense. So if you're not already a subscriber, become a subscriber, click like, spread news of this channel, because guess what? One day I'm not going to be around anymore. And if others don't get to hear about this, my enemies are no doubt going to try and bury this information and keep you and others from learning anything else. So with this, I leave you wishing you all the best. Those of you who are my supporters, thanks for your support. And remember that I'm doing this for the youth of the world, those who are who have the burdens of those stupid morons in the mainstream, the lecturers and mathematics teachers, placing burdens on them that they don't need in their lives. In fact, sound mathematics doesn't require axioms. It doesn't require the nonsense that most students are being taught nowadays, and it could be improved drastically. And that's one of my goals. Hopefully, I'll be able to help with that a lot more in the near future. So, this has been a presentation on the new Calculus channel. My name is John Gabriel. Till next time, goodbye, folks.